Now, Bohr's atomic model theory based on quantum theory of radiation and the classical laws of physics. K in bracket ZE bracket E upon R square is equal to mv square upon R. mvr is equal to nh upon 2 pi. mvr is equal to nh. Electron remains in a stationary orbit where it does not radiate its energy. Radius r is equal to 0.529 into n square upon z angstrom. Velocity v is equal to 2.188 into 10 to power 6 z upon n m per second. Energy, kinetic energy plus potential energy is equal to total energy is equal to minus 13.6 into z square upon n square ev per atom. Total energy is equal to minus kjd square upon 2r. Pe is equal to minus kjd square upon r. Ke is equal to kjd square upon 2r. Pe is equal to minus 2 ke. Ke is equal to minus te. Pe is equal to 2 te. Revolutions per second is equal to v upon 2 pi r. Time for one revolution is equal to 2 pi r upon v. Energy difference between n1 and n2. Energy level del E is equal to E n2 minus E n1 is equal to 13.6 z square in bracket 1 upon n1 square minus 1 upon n2 square. Ev upon atom is equal to IE into in bracket 1 upon n1 square minus 1 upon n2 square, where I is ionization energy of single electron species. Ionization energy E infinity minus E ground state is equal to 0 minus E ground state. E ground state is equal to energy of electron in ground state. Hydrogen spectrum Rydbergs equations. 1 upon lambda is equal to V is equal to RH in bracket 1 upon n1 square minus 1 upon n2 square into z square. RH approximately is equal to 10,9,700 centimeter inverse is equal to Rydberg constant. First line of a series n2 is equal to n1 plus 1. Limiting a spectral line series limit means n2 is equal to infinity. H infinity line means n2 is equal to n plus 1, also known as the line of longest lambda, shortest v, least e. Similarly, HB line means n2 is equal to n1 plus 2. When electrons de-excite from the higher energy level n to ground state in atomic sample, then the number of spectral lines observed in the spectrum is equal to n in bracket n minus 1 upon 2, where electrons de-excite from higher energy level n2 to lower energy level n1 in atomic sample, the number of spectral line observed in the spectrum is equal to n2 minus n1 in bracket n2 minus n1 plus 1 upon 2 spectral lines in a particular series is equal to n2 minus n1. Limitations of Bohr's theory. It could not explain the spectra of atoms having more than one electron satisfactorily explain the distributions of electrons in an atom. It could not explain the splitting of spectral lines under the influence of magnetic field, Zeeman's effect, and the electric field Stark effect, dual nature of particles, and the uncertainty principle was ignored in the Bohr's model.